Recording in progress.
Yeah. Let's start off. Good evening, everyone. So last thing that we did, yeah, with a horizontal acceleration. Next thing, other scams on. Projectile on an inclined plane. Let's see. So let's say we got an incline here where the angle of inclination is alpha, and you're projecting a particle here with speed u at an angle theta. So this particle goes here and will land somewhere on the incline like this. So this distance is called range. So this is the range on an incline. So theta is your angle of projection with respect to the incline. So normally we used to take theta with the horizontal, but we are not taking theta with the incline. Alpha is your angle of inclination. This is the angle made by the incline with respect to the horizontal. If you make alpha 0, it becomes your regular projectile motion. So the question is, we want to find that range. So if you throw particles on an incline like this, how to do? Now, one way to do is, you can solve this problem normally. Just assume you projected this theta plus alpha, then it lands here, let this be y coordinate, x coordinate, and then you can solve all that, you'll get an answer. But sometimes it becomes really inconvenient to solve that way. So there's a way to do this. Now, if you go back to the derivation of the projectile motion, I'll remove the people whose cams are not on. So I won't repeat this thing every time. I don't know why this is something new for you guys. So if you remember the whole thing here, what did we say? We study this motion by resolving the motion along two perpendicular directions. I never said it should be horizontal and vertical, isn't it? So you will get the thing as long as you divide the motion along two perpendicular directions. So I can choose them any way I want. So whenever you take an incline, the better way to take the direction is this. So I will choose along the incline, this as x-axis. I will choose this thing as y-axis. I can choose my x and y-axis any way I want. This angle is alpha. So now when you look at the gravity here, this is g. If that is the incline there, let me show you the components here. If this was alpha and if this was gravity, this angle will be alpha. This angle will be 90 minus alpha. So if you resolve this into components, this component will be g cos alpha. This component will be g sin alpha. Do you guys remember this? We have done this in vectors. Do you remember where? Resolution of vectors. This problem. If you keep a block on an incline, how are the components? This will be the sine component and this will be the cos component. So when you resolve the components, this g can be resolved into two parts. So this component will be g sin alpha and this component will be g cos alpha. That means for a person standing on the incline, he will think this way. The gravity has become g cos alpha, and doesn't this g sin alpha look like wind ka problem now? If you just rotate the page some angle alpha, don't you see this thing? It looks vertical. I'll show you that. And you're projecting with u and theta. So these components will be u cos theta and u sin theta. So if you just tilt this whole setup, this whole problem looks kind of like this. A particle is projected with u and theta, where the gravity has become g cos alpha vertically, and the horizontal acceleration has become g sin alpha. This looks similar to the wind problem. Doesn't this look like this? So in the place of g, we have g cos alpha. In the place of a, you have g sin alpha. This thing looks like similar to problem 48. Is this clear, everyone? Then you're done. If it looks like that, then I got everything here. So this g sin alpha is your ax, g cos alpha is ay, u cos theta is ux, u sin theta is ui. Time of flight depends only on the vertical component, which is 2uy by ay. uy का place में है अब u sin theta, ay का place में we have g cos alpha. This is the time of flight. This is the time taken for the particle to land on the incline. What about the range? We'll take the x coordinate. So sx is equal to ux t plus half ax t square. So be careful with the sign convention. If you go up, it is positive. If you come down, it is negative. So in the direction of x is positive, here ax is negative. So this will become range. Ux is u cos theta. T becomes time of flight. This becomes half. Ax will be g sin alpha minus sign because it's opposite to the u cos theta there. And this is time of flight square. Take that thing and substitute here. You get u cos theta to u sin theta by g cos alpha. Now, no need to remember this, but remember how we derived this, the time of flight and Sx. This will be 2u sin theta by g cos alpha ka square. There, that will give you the range. Now, if you want to find the maximum range, we have to do maximum minima. Now, I want to know with what angle should I throw so that I'll get the maximum range for a particle. So for a maximum range, we need to do dr by d theta is 0. Here, remember alpha is constant, theta is variable. So we'll not do that. I'll show you the result, but have a look at this. So the main thing in this question is the time of flight. Once you got that, I can use Sx is equal to ux plus t half ax is t square, and that will give you the answers. Any doubts on the steps? Are you clear how we did this thing? Doesn't this problem look kind of like this wind ka problem? Only thing g ka place we have g cos alpha, a ka place we have g sin alpha, and everything else looks the same. All got this? Then when you differentiate this, we get a maximum range. We have two cases. Case one, when you throw up the incline. If you throw up the incline, you will get maximum range. Is u square by g into 1 plus sine alpha. And this occurs when the angle theta is given by pi by 4 minus alpha by 2. Remember, if you throw with 45 degrees, you get maximum range in the horizontal plane. But on an incline, it is pi by 4 minus alpha by 2. Alpha is the angle of inclination. Case 2, if you're throwing down the incline. So if you're throwing down the incline, the formula changes. Max range is u square by g 1 minus sine alpha. And this occurs when the angle is pi by 4 plus alpha by 2. If you make alpha 0, it becomes your regular incline, and then you get your regular formula. You should note them down. Meaning these things, if you remember, great. If you can't remember, then you have to derive them, which will take time. But it is possible to do, but it will take time. I though won't recommend it. I can't derive it in less than a minute. So I will remember it. All clear with this. So the idea is pretty straightforward. If you got an incline, just split the motion along x-axis, y-axis, that is along the incline, perpendicular to the incline. Divide the components into g cos alpha, g sin alpha. It becomes like Windka problem. Time of flight depends only on the vertical direction. So that is 2 uy by ay. Uy has become u sin theta, ay has become g cos alpha. Once you got the time of flight, the horizontal coordinates will be sx is uxt plus half axt square. Substitute that, you'll get the range. Here, there is no concept of Hmax. Why? If I try to use Hmax formula, what will I get? If I try to use Hmax here, I will get this height, isn't it? That is useless because if the particle is going and coming down like here, this could be the Hmax, isn't it? So here, there is no meaning of Hmax. You want, you can find the perpendicular distance to the incline, but yeah, that is not called Hmax. All clear with this thing? Arya.
So we could find the equation of trajectory for alpha plus theta and then
You can do
get
that.
the
That's what I
highest
told in the
point.
beginning. I told you that's what you can do in the beginning. Yeah, you can
Okay.
do that. But that is of no use right now. Meaning, I'm saying if you try to use a regular Hmax formula, what you'll get is this Hmax. Yeah? That's it. So in terms of theory, there's not much there. So let's see a problem. That's the best way to get used to it.
So can
Let's
you
start with
show the
something simple.
slide, please?
Which slide? All clear with this page? Now, how did we get this? By actually doing maximum minimum. I didn't do that derivation. You can check it out. So you take this quantity, differentiate with theta, and then equate it to 0. Clear, na, Aditi?
Sir,
Srihaji?
previous page.
Advai.
Can you show the previous page, sir?
Clear? Let's see a problem then. We got an incline here. This is 30 degrees. Someone projected with 20 meters per second at an angle of 30 degrees. Find range. There, direct formula thing there. There's nothing there. Standard one. T minus 10 by root 3. Or such a bad number. Nah, re. 26.66. Trishi. What to do? Step 1, resolve the components. This is 30. So acceleration will be g sine 30. This component will be g cos 30. The velocity will be, this will be 20 cos 30. This will be 20 sine 30. This is your uy. This is your ux. This is your ax. This is your ay. This is the first step, uy. Once you got everything, the time of flight is nothing but 2u vertical by a vertical. So in this case, this is my x-axis and that is my y-axis. So 2uy is nothing but 20 sine 30. G is nothing but g cos 30. So g ka place mein we got g cos 30. That would be 4 tan 30. That is 4 by root 3 seconds. This is your time of flight. You will hit the ground in this much time. And for the range, we want to find the x coordinate, which is nothing but ux into time of flight plus half ax into time of flight square. So check out here, ax and ux are opposite direction. So it is opposite to the x-axis. So ux is 20 cos 30, 20 root 3 by 2. Time of flight is 4 by root 3 plus half ax is minus, so minus g sine 30, so g into half. And time of flight square is 4 by root 3 ka square. Simplify this, root 3 goes off. This would be 40 minus, that would be 10 by 4. That is 16 by 3. That is 4 za 40 by 3. 80 by 3 meters. Check. Yeah, right, Samyak. Check it out. See where it went wrong. Be careful, you have to subtract them because the u cos 30, ux and ax are opposite. So it's decelerating in the x-axis. Any doubts on this? That's it. This is the process in inclines. You see in incline motion, this is how you start. Resolve, put your x-axis along the incline, y-axis perpendicular to the incline. Resolve the velocities along the incline, perpendicular to incline. Resolve the acceleration along the incline, perpendicular to the incline. Rotate the page by some angle, and you will see this has become like a wind problem. Time of flight depends only on the y direction, so it is 2ui by ay. Range depends only on the x-axis, so ux time of flight plus half ax time of flight square. All got this? Let's see one more like this. Any doubts on this? We got an incline here. This is 37 degrees. Someone launched a particle here with u is equal to 10 meter per second horizontally. So this is also 37 degrees. Find range. Same thing. This time I'm throwing from the top. $25. Okay, let's see. Anyone else got that? I don't think so. That is 25. 25. Okay. Let's see. We have 225s, 325s. Interesting. Maybe right then. I was not expecting such a good number though. Could be. $21 by 4. 12 plus 27. Actually, I'll simplify that, Nare. Who will type an answer like that? 18.75. Just leave it in fractions. Nare param. Abhi count simplify karega. I don't know. Could be right. Maybe. I don't know. Let's see. 25. We got so many 25s. Let's see. I don't know why we're getting 25s. Could be right. I'm not sure. Shreyansh got 75 by 4. Let's see. Step 1, resolve the components. Standard story there. So this is 37. So this time, since you're projecting it down, this is my x-axis and this is my y-axis. This will be g sine 37. 37 is 3 by 5. So that will be 6 meter per second square. This is g cos 37, which is 4 by 5. So this is 8 meter per second square. Your velocities, this will be u cos 37. So this is 10 cos 37. 37 is 4 by 5. So that will be 8 meters per second. This will be 10 sine 37. That is 6 meters per second. So this is your ui. This is your ux. This is your ay. And this is your ax. Time of flight depends on 2 u vertical by a vertical. U vertical is 6, a vertical is 8. This is 3 by 2 seconds. And for the range, we use ux, time of flight, plus half ax, time of flight square. Now remember here, ax is positive. It is in the direction of the velocity, meaning both are in the same direction. So we'll take that as positive. The ux will be 8 and time of flight is 3 by 2, plus half ax will be 8 and time of flight square is 9 by 4. This doesn't look like 25. This is 12 plus, no, it's looking like 25. Did I goof up something? No, ax is 6 here. You guys took 8, I guess. That's why you got 25. That should be ax. Now ax is 6. So this is 12 plus 27 by 4. That is 48. 48 plus 27. 77 minus 75 by 4. Shreyansh got it. All of you did that mistake. You took ax is equal to 8. That's why you're getting 25s. See where it was wrong. Samyak also got 75 by 4. 75 by 4 is how much? That is 18, yeah, 18.75 something. Yeah, Param also got it. Check. There we have 3 answers for this. Easy, everyone. So you just have to be careful. If you're throwing up, the horizontal acceleration will be negative because it is opposite to the u cos theta. If you're throwing down, then take down as x-axis. So basically, whichever direction you throw, choose that direction as x-axis. Is this making sense? So it should support the motion. So definitely. Next one. Any doubts on this? Clear, na? Devanshi? Arya? Shreyan? Sudiksha? Clear with this? Next thing. We have a particle here. When you projected the particle with speed u at some angle, the range is r1. The same particle, when it is projected with u, the range is r2. R1 is maximum range. So when the particle is thrown from the down, the maximum range is R1. When the particle is thrown from the up, R2 is the maximum range. And it is found out that ratio R2 by R1 is 3. Then find alpha. Alpha is the angle of inclination. These are the formulas you need to use. Note it down in case you don't remember. So when you're throwing up, this is the maximum range. When you're throwing down, this is the maximum range. And in the question, it is saying this is 3 times of that. So if you know the result, question is straightforward. For people who don't know the maximum range of formula, you will derive the whole thing. That's where the question becomes tough. You know the result, it is easy. If you don't know the result, you have to derive the whole thing. There, while u square by g 1 plus sine alpha and u square by g 1 minus sine alpha. Got this? Now get it. It is easy. You'll get a minute. Yeah, right. It's not. Just a substitution. There's nothing there now. Get it. Mere param. That is wrong. Check your calculations. How are you guys getting 90 रे? 90 मतलब पता है डायग्राम कैसा है? It is like this. There is no incline. The answer what you got doesn't make sense. Ah, Siddesh, you got it. Shreyansh, you got it. Anshika, you got it. So R2 by R1. R2 is nothing but U square by G. R2 is the one when you're throwing down. So 1 minus sine alpha divided by G into 1 plus sine alpha by U square. This is equal to 3. U square goes off. G goes off. 1 plus sine alpha is 3 minus 3 sine alpha. You get 4 sine alpha is equal to 2. Sine alpha is equal to half. 30 degrees. Clear?
Can you show the question again? Oh, I wrote R1 upon R2 is equal to 3. That's what I was getting.
Logically, सोचो ना यार, when you're throwing down, you should get more range than when you're throwing up, isn't it?
That's why I was confused to what's happening.
Easy? All got this? So that you should know the maximum range of formula. Next one. Any doubts on this? Next one. Just a substitution there. This is alpha. So we have a particle projected with u and theta. So this particle goes and hits the incline perpendicularly. So this thing goes and hits the perpendicular to the incline. Find the relation between theta and alpha. The particle hits the incline perpendicular to the surface. Find the relation between theta and alpha. नहीं रह रहे थे. And why did you get a minus sign? Angles will become negative, na? How do we do this? Try. I'll give it a minute or two. Cot theta. Yeah, oh, yeah, that is right. Always, I keep telling you, draw the picture.
Recording in progress.
If you draw the picture, what are the accelerations? This guy is g sine alpha. This is g cos alpha. This velocity will be u cos theta. This will be u sine theta. Now, when you're hitting this incline here, look at this thing here. At this point, remember, this is your x-axis. So there will be Vy, but a Vx will be 0. Agreed? So when you're hitting the incline, there is no horizontal component of velocity. Vx is 0 since you're hitting perpendicularly. There, that is your second data point. So when you're colliding with the incline, there is no horizontal component of velocity. So first thing, time of flight will be 2uy by ay. This is still valid. That will be 2u sine theta by g cos alpha. Second thing, when I write the horizontal velocity, I know Vx is equal to ux plus axt. So here Vx is 0, ux is u cos theta, and ax will be minus g sine alpha into time of flight. Is that the meaning of it? By the time the particle reaches the ground, the horizontal component became 0 at the same time. So in time of flight, the horizontal component becomes 0. So this will be u cos theta, g sine alpha, and the time of flight is 2u sine theta by g cos alpha. G goes off, u goes off, bring everything to one side. You'll end up with 2 tan theta. Tan alpha is equal to 1. Clear with this. So you can rearrange it tan, cot, and wall, but yeah, that is the thing. That is the main idea there. By the time the particle reaches the ground in time of flight, during that same time, the horizontal velocity has become 0. That is the meaning of hitting perpendicularly. All clear with this? So these will be like a decent mains level questions. Let's see how they can frame a question in advance. Any doubt so far? I hope you're getting the idea in inclines what to do. You see an incline, just draw an x-axis, y-axis, and finish it off. Now, in exam like advanced, they won't ask questions like this directly. This will be part of some other question. Like, I have to show you. There was a question we did in work per energy for your seniors. Look at this thing. So there was a question like this. So there was a pendulum like this. Someone gave some speed u. This particle goes up, and then the string becomes loose, and then it flies and falls back on the point of suspension. Can you see the picture? How is the thing? So we have a pendulum here, and when you projected it, this thing went like this. Somewhere here, the string became loose, and this particle came and fell down on the point of projection. So this is actually a projectile on inclined. So this will be a part of some other thing. So you will get questions of that sort. We'll see when it comes, but yeah, let's say something else. Let's say this is 30 degrees. This is 60 degrees. So you have two inclines like this. So you projected a particle from point A with speed u perpendicular to the incline. So this guy went and hit this incline again perpendicular to the incline. He was hitting at point B. You're getting it? You went with speed u, you hit the incline with speed v at point B. So it's projected perpendicularly and hits this thing perpendicularly. And let this height be hb. Let this height be ha. The particle is projected from point A perpendicular to the incline. And it hits the other incline again perpendicularly. And let's say u is given as 10 root 3 meters per second. This information is given. So the initial speed of projection is 10 root 3. First question, find time of flight. Find v. So find the speed with which it hits the incline. Find HA and HB. This could be a decent paragraph question. HA and HB are the heights of the point A and B from the ground level. Gravity is there as usual. If you ask me, right, finding V is the easiest one. Let's start from there. How to find V? Think about that. Start from there. I'll give you a minute or two. Then we will go one step at a time. Let's start with V. Okay. Samyak, you got the time also? Right, Samyak. नहीं Utsa, that's not the answer. Right, Samyak. Speed भी आ गया. Get HHB. Right, Ishman. Get this. Get HA and HB. Try, everyone try. I'll give you a minute more for the speed. Everyone should try. It's okay, completely fine if you don't get an answer. But I want you to try. Give it a try. I'll just get some water and come. Let's see, anyone got the speeds? B is wrong, Risidesh. Okay, let's see the speed part. Now, for finding speed, right? You don't need all this incline and all that stuff. There is a much faster way to do this. See, So this is 30, this is 60. And what makes me think that way, that is the easiest one, right? The moment you see the initial speed, final speed, and you see angles, and the only thing that I remember is u cos theta is v cos alpha, isn't it? So here, when you're projecting this perpendicularly with the horizontal, what is the angle? This is 30, so this is 60, and this is 10 meters per second. When you go here and land here perpendicularly, this is v. If you draw the angle, this angle is 60, that means this angle is 30. And we know in a projectile motion, it doesn't matter whether you're throwing from incline or anywhere, u cos theta is equal to v cos alpha. The horizontal velocity remains same. The u is given 10 and theta is cos 60. V I don't know, and this is cos 30. Right? And how much is this?
So I think
So
you had
u is
given
given,
u to be
u is 10
root
root 3. Yeah, u is 10 root 3. So 10 root 3 cos 60 is half, and this is v, and this is root 3 by 2. So v is 10 meters per second. There, you can just use it directly, then finish it off. Yeah, there are other ways to do, but I find this is the easiest one to do. All you're interested is only this angle here, 60. And this angle is 60, and that angle is 30. You should take the horizontal components.
So I did the dot product, but I'm getting, means the V is getting cancelled.
Why are you doing dot product?
I mean, they will be perpendicular, right?
Who said? Which two?
The V and U.
Okay, then.
So I did the dot product, they are perpendicular. But I think
But how did you find V and U?
No, I represented them as vectors in the components.
Then how did you do that? Matlab, which formula did you use to represent them as vectors?
I splitted them across the plane.
But then in that term, where is the time ka term?
No, we know U, right? So I thought that we'll get the value of V for U dot U is equal to 0.
God, if you divide U into components, you'll get U cos theta I cap U sin theta j cap. If you divide V into components, you'll get V cos theta I cap V sin theta j cap. इसमें time का term कहाँ पे है?
No, I was finding it for V, not for T.
ठीक है, but got it, that doesn't work. Clear with this?
So they are not perpendicular to each other.
They're perpendicular, but you got nothing.
That means they everything got cancelled.
Yeah. So you proved na 0 is equal to 0, which is right. Or 1 is equal to 1. You're not wrong. You have proved that the 1 is equal to 1. Mathematical genius. Happens. Did you ever prove 1 is equal to 2? Did I show you guys this thing? I think I taught you this once. 1 is equal to 2. I proved it once. Yeah. Anyway, let's go ahead. So that is the first part. How do you find the time of flight? Now listen. One thing, if you see this incline, right, this is actually 90 degrees. That should have given you some ideas. So I will choose this as my x-axis, and I'll choose this as my, I can choose anything. I'll do one thing. I'll choose this as y-axis. I will choose this as my x-axis. This particle is projected with u. So this guy goes here and lands here like this v. Now get your data clear, okay? So at this point, this is perpendicular and this is perpendicular. So initially, ux is 0 and uy is 10 root 3, which is u. When you're hitting this ground here, you can clearly see your Vx is 0 and your Vy is V. Is that clear, everyone? So when you're launching at the point of projection, there is no velocity in the x-axis. There is only vertical velocity. Y direction, there is a velocity. But when you're landing on the other incline, there is no velocity in the x direction. There is only velocity in the, I wrote reverse, I guess. Vx is V, Vy is 0. So when you're landing on the particle, there is no component in the y direction. Is that clear? This is 30 degrees. So you're interested in this incline, you're getting it. So when you divide the components of acceleration, so this guy will be g sine 30. This will be g cos 30. So we are studying for the incline from where you're launching. I don't care about the incline where you're landing. Any doubts on this data, please ask me. Then we can use the formula Vy is equal to Uy plus Ay into T. So when you're landing, Vy is 0. When you're launching, Uy is U. And Ay, so this guy is your Ax and this guy is your Ay. Your Ay will be minus g cos 30. And since you're landing there, this becomes your time of flight. Don't use the formula 2u sin 2u by Ay. Why doesn't this work? Are you coming back to the same level? You can't use. This formula was derived under the assumption when you launch it, you came back to the same level, isn't it? It is not coming to the same x-axis, so you can't use that formula. So this is the time of flight here. In this case, it will be u by g cos 30. U ka value is 10 root 3, g is 10, cos 30 is it root 3 by 2. 2 seconds. Got this? Any doubts on this? Once you got this, now if you look at this thing, this is your y coordinate. This is your x coordinate. So this is your point of launching. Then I can use my displacement equations. Sx is equal to ux time plus half ax t square. So in time t, this thing has traveled an x coordinate. X is equal to ux is how much? 0 plus half ax square will be g sine 30. And the time is 2 square. This will be 10 meters. I found x is 10 meters. X is which distance? This distance. Similarly, I can use sy is equal to uyt plus half ayt square. So I'm studying everything in terms of this incline. Yeah, bolo.
So can we solve this using energy?
Energy will never give you time.
I'm talking about the like we found the time to be 2 seconds, right?
So you have an idea, right? Try it, send me the working, then I'll tell you whether you did it right or wrong.
Okay.
See, it is always important. You have ideas, that is good. But you should first try it on your own and see whether you're getting an answer, and then you should send it for review. Right? It's good to get ideas, but just don't throw it on the teachers. You should try it on your own because in the exam I won't be there to come and help you. So try, it's a good idea, but I don't think it will work. Because when you want to use energy, you will get, you know what? You will get the difference in height. You will not get the individual heights, you will get difference in height. Try करके देखो. Then sy ui will be what? Ui is u, right? And the time of flight is 2 seconds. So u is how much? 10 root 3. Ay will be opposite. So this is minus half ay. This will be 10 root 3 by 2. And this is 2 square. This is 10 root 3 meters. There, I got x and y coordinate. This is not what I asked you. But have a look at this. I'll turn the page. So what did we find exactly here? This was A. This was B. What you found is this distance. This was X, which was 10 meters. You found this distance. This is Y, which is 10 root 3 meters. And what did I ask you? I asked you this height, HB, which is 60 degrees here. I asked you this height, which is HA. This is 30 degrees. So HA is 10 sine 30, which is 5. HB is 10 root 3 sine 60, which is 15 meters. All got this?
Could you go to the previous slide for a second?
Yeah.
All right, sir. Okay.
Have a look at this. This is the main thing anyway. Once you got x and y, you'll get the other things. Why bol raha hu Arya? What you did now, if you use energy, you will get the difference in height.
So we found the velocities, right? So we can directly calculate the angle of that right angle triangle so formed.
And
then we will just express each of them in terms of the
करके
trigonometric
देख
ratio.
करके देख
So, I mean, like you found the x using the
find na
displacement
get it
function,
na
right?
find it na Arya. Try and then send me the answer na. See, if you got an answer, I'll agree na. Why do I have a problem? I'll be happy if you got it in another method. And if you found a method which is faster than what it did, let me know. I'll be really happy. I will teach that method only to everyone from the next batch. Your seniors have done that a lot. There are many questions where some of the seniors, right, they have given better ideas and better hints. I incorporate them. Nothing wrong. People get different ideas. Clear with this? I still remember there's one question in Doppler effect, which it takes me around half page to solve. So there was a question like that. We'll see later on. And this was 2021 ka batch, I guess. And that guy says, he told me something which I could solve it in one line. Huh? And I was like, shit, remaining it was there right in front of me and I didn't see it for years. Happens. So that is a good thing. If you are doing something like that, that means you're better than me. That means you'll get a better rank than me. Then I'm happy about it. That is the whole point of the 2-year course. You should become better than the teacher. Clear with this? This is a good one. You should definitely try this on your own again. This thing actually becomes a little easy because, this angle became 90. If that was not 90, things would have been a little more difficult, but you could have still handled it. Next thing. So that is a little about the inclines. Now let's do a little other variety. Let's say we got a wall here. At a distance d. This is an elastic wall. I'll tell you what it means by elastic wall. So here, when you throw a particle with u and theta, listen to the class, everyone. You can do your things otherwise later on. So you guys need to listen when I'm explaining stuff. So this thing goes here, hits the wall, and then bounces and falls back on the ground. I'm pretty sure you must have done something like this. You take a ball, throw it onto the wall, it hits the wall and comes and falls back on the ground, and the distance is x. So what happens with an elastic wall? So whenever you have an elastic wall, whenever you throw a ball, if the velocity is vx and if the velocity is vy, this is before collision. So you can clearly see here, whenever this thing goes and collides with the wall, only the vx ka velocity will get reversed. The vy will remain same. Is that making sense? Only the component along the normal will reverse. This is after collision. Does that kind of make sense? Think about it. If you have a wall here, if a ball goes here, won't the ball just bounce back like this? But if you take a ball like this and throw like this, what will happen? The ball will just keep going parallel, right? It will not touch the wall only. So that means whenever you throw a ball onto a wall, only the velocity perpendicular to the wall will get reversed. The parallel velocity will remain same. Is that making sense? So for an elastic wall, the component of velocity perpendicular to the wall gets reversed. The other component remains same. There, I explained you something new called elastic wall, and the parallel component remains unaffected. That is what an elastic wall does. Right? So we have range is equal to u square sine 2 theta by g. And let's say it is given r is greater than d. Find x. Yeah, it's an easy one. Try, but it's a, think about it. Arya.
So whatever was going to be like the expected trajectory, it's mirror
No,
image of.
Arya, I know. Patience. Let others also try. You sent it right. I said it is right, so let it be. You try that thing now, which you're trying now. Others try. You got an answer, type in the chat box. I know most of you know some questions. It doesn't mean let others also try. It is a good strategy, actually. Once you're done, you can tell the answers and make sure others don't think. You can mess up their rank. It works. How do you get a better rank? You study well and make sure others don't study. Try. But I hope, is the scenario clear, everyone? A ball is projected with event theta. It goes and hits the wall elastically and comes back and falls on the ground. And it is an elastic wall. So whenever you hit a wall, only the component perpendicular to that will get reversed. The vertical component is unaffected. So find x. Answer comes in terms of R and D. Any answers? I thought you guys will just see and tell. There's some kind of symmetry there. When you see it, aren't you getting a feeling like, oh, it could be like this? There we have one answer from Arya. Others, anyone else? Right, Srihari. Near Shreyansh, that's not the answer. Samyak, right? There we have 3 people. Someone else got. Param also got it. Let's see. Then listen. So we got the wall here. So when you launch this particle with u and theta, and when you're going and hitting this wall, look at the velocities, okay? At the point when you're colliding, the velocities will be u cos theta, and the other component will be vy. This can be up or down, it doesn't matter. So just now I said, only the component will, the horizontal component will get reversed. If this is distance d, imagine there is no wall. What do you think would have happened? If there is no wall, this would have continued here, would have landed here. This part would be r minus d. Do you agree? Because the total distance must be r, no? If the wall had not been there, you would have gone and landed at r. Now you went and kept a wall at the distance d. So now what will happen after hitting the wall? Only the horizontal component gets reversed. So this guy will become u cos theta, and this guy will still remain vy. Means whatever supposed to happen on the right hand side now will happen on the left hand side. Do you agree? It kind of looks like a mirror reflection, isn't it? The only difference, instead of throwing horizontally, if you throw it left hand side, what will happen? This motion, they will look identical, isn't it? Because the vertical velocity is same. So whatever motion that is supposed to happen on the right hand side now will happen on the left hand side. So if this was the motion, you just flip it here. So if this distance was r minus d, the same thing will happen on this side. This also will be r minus d. Therefore, x is r minus d. So basically, since u cos theta reverses, the motion looks like a mirror image. About the wall. So you can treat the wall like a mirror and then just put a reflection of it. Is that making sense, everyone? So there's no need to use big equations and everything. You can just use symmetries and solve. Clear? Any doubts on this logic? This logic is important. We will see a few more questions on this. All clear with this? Take a small break. Come back by 5 minutes. Any
Sir,
doubts so far? Aditya.
not a doubt, but I was having some issues while I was giving the test.
We'll see end of the class. We'll discuss.
Yeah, okay.
Arya.
Sir, I got the answer using that method.
ठीक है photograph भेज देना. Let me see what you did.
Okay.
Anything else? Go take a 5-minute break and come back. So we have a particle here projected from this corner, u and theta. We have two walls here. Both are elastic walls, and the distance between them is 3r/13. And you projected a particle from the corner with u and theta. So what will happen to this particle? This will bounce, 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 and it'll just keep bouncing between the walls. The question is, find the point where it lands. Gravity is there. Right, and find h max in time of flight. Let's get this. I can even ask you this many questions. How many collisions will happen with the walls? Let's get this. Hope the question is clear. We got two walls. Parallel walls, distance between them is 3r/13. You projected a u and theta from the corner. This ball will bounce between the walls and it will land somewhere on the ground. Find the point where it lands on the ground. Find time of flight and h max. By 13. Yeah, get me the position. That's what I'm more keen on. Find the point where it lands. Someone got it. Shreyansh got it. Take your initial point as origin. Start from there. Find the point where it lands on the ground. Anyone else? So how to do these kind of questions? See, if suppose the wall is not there, what would have happened? If the wall is not there, this thing would have simply just gone like a regular parabola. Now what you're doing, you're trying to put this parabola between two walls. So can I simply say like this, every time you hit a wall, you will reverse? So this is like you take a parabola and you're folding it, isn't it? You're folding it with a distance of 3r by 13. So take a parabola, cut it into pieces, 3r by 13, 3r by 13, 3r by 13, 3r by 13. The last piece will be r by 13. Is that making sense? So if I take this points here, if I call this point 1, that means this motion will look like this. So you'll hit here at point 1. Then if I mark this with green color, you will hit at point 2. If I mark this in some black, you will hit here in some point 3. It's not exactly, I'm not putting it, but then if I mark this thing in some other color, this will hit at point 4. Then the last piece, if I take this here, you land here. This is 0.5. Is that making sense what we did? You simply take the parabola and fold it for every 3r by 13, keep folding it onto itself. Because every time you hit a wall, you're simply going the one which is going front becomes back. When you hit the left wall, you go front. So you're simply going left and right, isn't it? You simply fold the parabola. So the last piece will be how much? R by 13 from the left hand side. Easy. And in this process, you notice when you're colliding, only the horizontal velocity changes. The vertical velocity is unaffected. The vertical components are unaffected. Therefore, your h max and time of flight will remain same. So h max will be u square sine square theta by 2g. Max doesn't care. It's like, what you do with the left and right, the vertical motion will remain same. Time of flight will be 2u sine theta by g. We are ignoring the time during collision. Is that making sense, everyone? Sure. Got this? That is what happens if you're colliding with the wall. So you can play around like this. Just let me ask you one more. Tell me what will be the answer for this guy. Let's say this is 5r by 17. And let's say launching from the midpoint. Let's make it 6r by 17. Now can tell me where it will land? There are two walls, distance is 6r by 17. You're launching from the midpoint. So this will bounce, bounce, bounce and land somewhere. Where will it land? Get this, 30 seconds. We'll do one thing. Let's make it, 4r by 17. Now do. Make it 4r by 17. Find the point where it lands. Okay. Which side, left or right? Three R by 17 left. Okay. Let's see. So take a parabola, cut this into pieces, 4r by 17. So this is 2r by 17, right? This side. So if you cut this into pieces, the first piece will be 2r by 17 ka piece. I'll hit somewhere here. This is 0.1. Then the next piece will be 4r by 17 ka piece. I'll hit here 0.2, so I'll hit somewhere here 2. Then again one more 4r by 17. One more 4r by 17. How many can I take? 4, 4, that is 12, 14 ho gaya. The last piece will be 3r by 17. So 2, and then you'll hit here 3, and then you'll hit here 4, and then you'll land somewhere here 5. So from the left hand side, it is 3r by 17. So it is r by 17 from the midpoint on the right side. So it will land somewhere here actually. The final piece will land here. R by 17 from the midpoint or 3r by 17 from the left corner. Clear with this? Then you just have to keep on breaking that parabola, you'll get the pieces. Got this thing. So there, this is one way of doing questions. Later on, we will see what happens if it's not elastic collision. Means every time it hits the wall, speed becomes half. Then the game is different. So we will handle those things later on in collisions. All got this thing? So there, that is a bit about the projectile motion. So we did projectile and incline and everything. The next thing is relative motion. Relative motion, the concept is pretty straightforward. Let's see that. So I will teach you in terms of directions, in most pictorial, we'll try to do it most of the time in terms of pictures rather than maths. That gives you a better, visualization. So when do we use relative motion? So we will see that also. So in certain cases, it is convenient to solve with respect to a moving frame. Right? For example, say, if I ask you this question, how is the moon going with respect to the sun? If you stand on sun and look at the moon, how does the motion look like?
Circular.
What do you others think? How does the motion of the moon look with respect to the sun?
Like jalebi kind.
Yeah, you can type it in the chat box, right? Type in the chat box. I know you're excited, but please do type in the chat box. Let others also give it a try. Don't do this. So how does this motion look like? We have discussed this before. If you look at this thing actually kind of looks like this. And if I ask you to study this, it becomes very complex, isn't it? It doesn't even look like something which we know. But if you suddenly split the motion into two parts, so if you have the sun and if you try to study the earth, we know the earth is almost going in a circle. And with respect to the earth, we know the moon is going in another circle. So if I ask you to study the motion of moon, the best thing to do is stand on the sun, look at the earth, and then stand on the earth and look at the moon. Getting it? So it is actually a combination of two circular motions. So this thing is actually a combination of two circular motions. So this is the motion of earth with respect to the sun. So first look at this earth. That is easy. You'll see a circle. Then look at the moon from the earth ka frame. Is that making sense, everyone? So you split the motion into two parts, so that will look more easy to see there. So how do we study, relative motion? So the idea comes from, Max, shifting of origin. I don't know whether you studied this or not. Let's say if there's a point 3, 4. If I want to shift my origin to 3, 4, what should I do? If I want to shift my origin to 3, 4, what is the technique? What do you guys do normally?
Take 3, 4. No, wait.
Take 3,
Nothing.
4.
Nothing.
That idea. So see, what we do, I'll tell you see the idea. Let's say, right, there are, let's say 5 of your friends, and let's say 4 people have, let's say you have 1 crore, okay? You have 1 crore rupees with you, right? And I want to make you poor. What to do? You have 1 crore with you, and I want to make you a poor person now. What to do? If you are a negative person, you will say, take away the money. The other idea is this. What if I give 1 crore to everyone? Or what if I give 10 crores to everyone? Now you're poor, right? So when you say rich and poor, it is all relative. Getting it? So that is a much positive, isn't it? Give more money to others, and you'll automatically become poorer than them. So something similar. So whenever you want to shift this thing at origin, what you can do, subtract -3 and -4 from everyone. The idea is pretty simple. You want to make 3, 4 origin, subtract -3, -4 from everyone. When you do this, what will happen if you have a point here 6, 7? So subtract -3, -4, subtract -3, -4. There, you have successfully created a new origin. This becomes the origin, and 6, 7 becomes 3, 3, and the old origin becomes -3, -4. Is this making sense? If you add -3 and -4 to everyone, the 3, 4 becomes the new origin. And similarly, all other coordinates will change accordingly. I'm pretty sure this is what you learned in max shifting of origin. So we are going to do something similar here. So what we do, we study relative motion. That's it. That is the main thing. If you understood that, then job's done actually. After that, it is all your regular kinematics. So we study relative motion. By subtracting velocity and acceleration vector of the observer from everyone. Comes on everyone. So let me take an example. With that, you will see. Let's say we have 3 people. So listen to this thing. Like I said, we will see more in terms of pictures. It will give you a better visualization. So let's say A is at rest. Let's say B is going with speed UB and acceleration AB. Let's say C is going with speed UC and acceleration AC. So listen to this carefully. This is what I generally do. So if you ask me, study with respect to B, means I want to make B as an observer. So if you want to make B as an observer, means what should I do? I need to stop B. How do I stop B? Subtract the velocity of B, subtract the acceleration of B. Now B will come to rest. Do you agree? Isn't that what we did in shifting of origin? But when I do this, I need to do this for everyone. That means I need to subtract B ka velocity and B ka acceleration from C also. So I have to subtract UB. I need to subtract AB. I need to do the same thing for A also. But A ka initial is already 0. So this is UB and this is AB. Now if you see, B has come to rest. Now B will think, okay, I came to rest. And B will start thinking that this guy C is actually going with a UC minus UB and is going with acceleration AC minus AB. And B thinks A is going actually backward with UB and AB. This is what B will start thinking about the world. This is the velocity and acceleration of C as seen by B. So whenever you stop B, this is what B will think about everyone. This is the velocity and the acceleration of C as seen by B. Is this logic clear, everyone? If you want to study with respect to C, then subtract UC and AC from everyone. Is this understood? That's it. If you understood this part, I think your relative motion, you got the basic idea what is happening. But let me take one more example. You can do this even in 3D. Let's say we have a point A here. You projected with U1 and θ1. Gravity is there. Let's say you projected another particle here with U2 and θ2. U1 θ1, U2 θ2, gravity is there. So this is the bigger particle. So whenever you get these things, what to do? First of all, resolve them. Let's say we want to observe motion of B as seen by A. So decide who is your observer. Right? So what we do? Subtract velocity and acceleration of A from everyone. So step one, first resolve the velocities into components. So point A, the horizontal velocity is U1 cos θ1. For point B, the velocity is U1 sin θ1. And we have a gravity also G. So point B, the velocity will be U2 sin θ2. This velocity is U2 cos θ2. And we also have a gravity G. So you want to stop A. So what should I do? Subtract velocity of A. So subtract U1 cos θ1 back. Now see, you're adding U1 cos θ1 back. So I should add U1 cos θ1 even for this guy. I need to add U1 sin θ1 down. That means I need to add U1 sin θ1 down even for this guy. I need to stop the acceleration also. I need to put G upward. So I'll put G upward also here. Are you getting what I'm doing? Everything of A, I'll subtract from everyone else. So once I do this particle A will think I came to rest. Everything got cancelled for A. And it will think now B is traveling upward with U2 sin θ2. So see, these two will subtract. U2 sin θ2 minus U1 sin θ1. It will think horizontally, these two will add up. U2 cos θ2 plus U1 cos θ1. And what is the acceleration? G and G got cancelled. So relative acceleration is 0. So A will think B is going in a straight line. This is the path of B as seen by A. There is no acceleration. So A thinks B is going with a constant velocity. Because the acceleration got cancelled. So you can do this in 1D, you can do this in 2D, it doesn't matter. If you have to do it in 2D, resolve the velocities along I cap, J cap, resolve the accelerations along I cap, J cap, subtract them from everyone, and then the body will come to rest and everyone else's velocities and accelerations will change. Is this clear, everyone? So once you do this, once this is done, then you can just solve the problem like a regular kinematics. All your formulas are valid. V is U plus AT, S is UT plus half AT square and all that stuff. I'll show you that. But is the idea clear what I taught you right now? So whomever you want to stop, take his velocity, take his acceleration, reverse them and add it to everyone. Clear with this? Now here, if you look at this, this was a theoretical question. What is the motion of one projectile with respect to another projectile? Straight line. If you throw two particles in the air and if you stand on one of them, you will always think the other one is going in a line because the relative acceleration goes off, becomes zero. So motion of a projectile with respect to another projectile is a straight line. So if I want to do this mathematically, this is how we write. The representation is like this: velocity a comma b. The meaning of this is velocity of a with respect to b. That is how we write this mathematically. So velocity of a with respect to b is nothing but velocity of a with respect to the ground minus velocity of b with respect to the ground. So if you subtract a velocity, b velocity from a, you'll get velocity of a with respect to b because you're stopping b. Whenever you say with respect to b, meaning b is the observer, you have to subtract its velocity. With this thing, I can rearrange the term. So I can write velocity of a with respect to ground is velocity of a with respect to b plus velocity of b with respect to ground. This thing looks like the moon example. See, velocity of a as seen by b and velocity of b as seen by the ground will give you a with respect to the ground. So this is the moon, this is the sun, this is the moon, b is the earth and sun. It's like that. Yeah, this is how you represent it mathematically. Next thing, you can use our kinematics equations. V relative is nothing but d r relative by dt. So if you find the relative position and differentiate it, you get relative velocity. A relative will be, if you take relative velocity and differentiate it, you get relative acceleration. This can be also written as v relative dot dv relative dr relative. So basically everywhere just put relative and you'll get all your kinematics equations. And if A relative is constant, then you can use your three kinematics equations. V relative is u relative plus A relative into t. S relative is u relative t plus half a t square. V relative square minus u relative square is 2A relative S relative. There. So once you subtract the velocities, the whole game just simply becomes like your regular kinematics, whatever you have done so far. Are you clear with the steps? So let me write down some steps to solve. So whenever you handle a relative problem, steps to solve. This is the process that you follow. Always, remember the process to solve, remember the process to, solve the problems. Don't mug up the problems because you can have hundreds of varieties, but once you know the process, you'll know how to adjust. Think of like cooking. Once you know how to cook one or two dishes, you can handle most of the other varieties, right? So you don't mug up the one thing, you mug up the process. Step 1, choose your reference frame. So let's say if 2, 3 bodies are going, you choose any one out of your own convenience. Basically an observer. Let's say A, B, C are moving and you decide whom you want to take. Sometimes it doesn't matter, you can choose any one. Step 2, once you decide the observer, subtract the velocity and acceleration of the observer from every body in the system. Subtract the velocity and the acceleration vector, if it's a 2D thing, of the reference frame from every system, including your own. You have to subtract that to the observer also, so that he'll become 0. Right? Third, then use your kinematics to solve. Once you have done that, relative motion is over. Then it is simply your kinematics ka problems. But the thing is this, how do you know you have to use relative motion? Again, this is not exactly a concept, but a general hint, right? Again, these things you will learn when you do a lot of problems. Let's say if there are multiple bodies moving, If there's only one single body moving, there is no relative motion. It doesn't make sense. So if there are multiple bodies moving, and we're interested in the motion between them, something related between them, distance between them, anything between them. That is a clue actually. Maybe relative motion can be used here. We are interested in the relation, between motion between them. We'll see some problems, you will understand. But that is the biggest clue. If you have only one particle moving on, relative motion is useless. You see 2-3 particles moving and they ask you find the distance between A and B. Maybe mostly relative motion might be valid. It works. All clear with the process? Let's see a question. Any doubt so far? Utsa, Siddesh, Vanshika, Tanishka, clear? Arya? Clear? Let's see a question. We'll do some basic ones today. Next class, we'll see some deadly ones. So let's say we have two trains. Train A, which is going with a speed of 72 kilometers per hour. Let's say you're Mumbai local. And as this train is going, the driver sees the train B, which is in front of the train in the same track, which is at a distance of 36 kilometers per hour. So the train A ka driver saw this train B at a distance of 1 kilometer. And train A is going fast. So if it doesn't do something, he will go and hit the train. The moment A sees the train B, B also realizes there's a train coming from back. This guy starts accelerating with A by 2 and train A starts decelerating with A.
Could you repeat the last line? The deceleration.
Yeah. Listen. Let me finish the question. So two trains A and B on the same track. Right? So they're on the same track. So when the distance between them is 1 kilometer, the train driver A starts decelerating. So he starts applying brakes. Normally this happens in our, Mumbai locals car. There is one train on a platform. There is one more train coming from the next station. So the train B starts accelerating, starts decelerating with A. And at the same time, B starts accelerating with A by 2. Not the same acceleration. So find the minimum value of A so that the trains don't collide. Let's say if the train driver A doesn't apply brakes really hard, it just applies little less. This will go and just hit the train B from the back. Or if he gets, hyper and he applies brakes too much, then the train will stop even before reaching the next station. So I don't want to hit the other train. I just want to avoid the collision. Haan Aditi, now bolo. Confused? Now got it, na? Yeah. There I know. When I said it, it is not clear. That's why I'm writing it down. Now try the question. This is a simple, straightforward 1D relative motion. And when you see a question like this, it is understood you have to use relative. See, two trains are going, right? Think about it. Till now, in all the problems, we rarely did anything where there are two things moving. Here, two things are going, and you're saying distance between them is 1,000. And you're saying find the time when they avoid collision. So you're talking about two particles which are moving. That is a big hint. Maximum, there is a relative motion involved. You can do this in ground frame also, but normally, relative motion makes your life easy. Try, I'll give you 2 minutes. Yeah, some people already got the answer. Yeah, right, Samyak, right, Shreyansh. Get it. I'll give you another minute or 1.5 minutes. Remember the steps. Step 1, choose your observer. So that is A or B. Choose any one. Preferably choose A. Step 2, subtract the velocity of A and acceleration of A from everyone. A will come to rest. There, you made your life easy. Instead of two particles moving, now there's only one particle moving. You know how to do for one particle kinematics. That's how you should think. Right, Param. नहीं आ रहा. Let's see. So first, let's convert the speeds into meters per second. So 72 kilometers per hour into 5 by 18. So how much will that be? So it's 20 meters per second. This is 10 meters per second. Step 1, choose your observer. I'll choose A. So we are going to study everything with respect to A. Step 2, you have to subtract A ka velocity. So I have to subtract A ka velocity, that is 20 backward, 20 backward. I need to put 20 backward for both of them. Subtract acceleration of A. So I need to keep A forward. I need to keep A forward. So A has come to rest. A ka velocities and acceleration got cancelled. A will think I am at rest. Now if you look at B, 20 minus 10, so now it will look like B is coming backward with 10 meters per second. And acceleration is 3A by 2. Isn't this what A will think? Is this making sense? So A will think this is what is happening. So how will the motion of B look like? So A will think B is coming backward, but it is decelerating, and you want to avoid collision. That means just before touching A, you should come to rest. So V relative must be 0. Is that making sense? Think about it. See, velocity is backward, acceleration is forward. What will happen to the vehicle? Won't it slow down? So the vehicle will slow down, and eventually it will stop just before colliding with A. And this distance is 1000 meters. There you have all the data. What is U initial velocity? Minus 10. What is their acceleration relative? 3A by 2 plus. Right positive, left negative. What is S relative? Minus 1000. What do you want to find? V relative is 0. So V square minus U square is 2AS. 0, 10 square, 2, 3A by 2, minus 1000. You get A is equal to 1 by 30. This is your minimum acceleration. Anything more than this, you will stop even before reaching A. Is this making sense, everyone?
So if we wanted to solve this with reference to the ground frame, then we would have to take the some variable time, and then for that,
You have to do that.
it covers more than the
It will take more
1000
time.
plus
Yeah.
S.
Why karna padega? Now tell me one thing here. I have a doubt here. When you say V relative is 0, meaning when the collision is avoided, should train A stop? If you want to avoid the collision, should the train stop? Think about this way. Let's say if you're running in front of me, let's say I'm running behind you to catch you. I'm running with 10 meters per second. If you don't want me to catch, what should be your speed? 10 plus something, or if it is 10, I can never catch you, isn't it? So the thing here is when you want to avoid the collision with the train, that train A need not come to rest. If the speed of train A becomes equal to speed of train B, the collision is avoided, isn't it? If the speed of both the trains become equal, the distance between them will not decrease and the collision is avoided. If the velocity has become equal, if VA becomes equal to VB, what is V relative? 0. That's what was happening here, isn't it? A will think B has come to rest. It doesn't mean A has stopped. I hope you're getting that point. So relative motion ka advantage, you know what? You get answers. But the problem, you actually lose information in the ground frame. You don't see the actual picture. It feels like B is coming to rest, but whereas in reality, B is not coming to rest. A and B are going with the same speed, the same velocity. So it feels it has come to rest. Is this clear, everyone?
Sir, they may be at rest too, right? We don't know.
In this case, it won't be at rest. B ka speed is increasing, na? How it will come to rest?
No, at a general, in
General,
general.
not. We're talking about this question.
Okay.
Clear
I
with this?
mean, they can be at rest or they can be moving with a constant
Hmm.
velocity.
Right. Let's see one more in 2D. This we have done in maximum minima. Let's say we have two particles here. Let's say this is A traveling with speed 2u, and let's say this distance is 0, d. This is particle B traveling with speed u, and let's say this distance is d, 0. I change the numbers. Find the minimum distance between A and B. If you remember there, the question was both had same speeds. The distance was d and 2d. Here I kept the distance same, but I changed the speeds. We did this problem in maximum minima. I can use relative motion 2D also. So same story. Step 1, choose an observer. Step 2, stop his velocity. Step 3, use kinematics. Okay, let's see, Arya. I don't know the answer. I just made up the numbers. D by root. Near Vanchika. You got the numbers wrong. Check karo. 2u and u, na, speeds are different. It's not d and 2d. Yeah, numbers will be a little bad here. Maybe I should have given the same numbers, but okay. Let me help you with this thing. Step 1. What is step 1? Choose an observer. Whom you want to choose as an observer, A or B? You can choose anyone. It works. I will choose B. We are taking A every time. Let's choose B. So let's study with respect to B. So B is going with U this way. A is also coming down with U. So if you do with respect to B, what should I do? I should stop B. So subtract U ka velocity on the right hand side. I should do the same thing for this guy also right hand side, isn't it? Now when I do this, the point B will come to rest. B will think, okay, I'm at rest. Wait, I took something wrong. That is
You
2u,
took
no?
2u.
This is 2u. This is 2u. I will keep it a little far. So this is B, it has come to rest. Now what happened to A ka velocity? Look at the A ka velocity. So A ka velocity is down is 2u and the right side is u. That means this A will start going something like this, a straight line. This is the path of A as seen by B. Are you getting this? So B will think now A is going in at an angle in a straight line. Do you guys agree with this? Now you tell me, what is the shortest distance between a point and a straight line? So if B is standing here and looking at path A, what is the shortest distance? The perpendicular. Isn't this the minimum distance? If someone is going in a line and if you're standing here, what is the shortest path? A perpendicular distance. Is that making sense, everyone? So the moment you stopped B, it comes to rest and the A is going at some angle now. You can figure out this angle also. How much is this angle? If you take this angle as theta, you can clearly see the velocity tan theta will be opposite side by adjacent side is half. There I know that angle theta. So this angle will be 90 minus theta. This angle will be 90 minus theta. This is theta. What is this distance here? D comma 0. So this distance is D. So this distance will be D sine theta. If this is D sine theta, this distance will be D minus D sine theta because the total distance was D. Therefore, D minimum will be D minus D sine theta ka opposite side, that is adjacent side, cos theta. Is that making sense, everyone? For this triangle, this is the hypotenuse and this is the adjacent side, the black line. And tan theta is half. So if I know tan theta, I can get sine and cos from there. So tan theta is 1, 2, and this is root 5. So sine theta is 1 by root 5 and cos theta is 2 by root 5. There you can check and verify the answer. So this will be D into, yeah, you won't get good numbers. 1 minus sine theta, that is 1 by root 5 and 2 by root 5. So if you multiply this, you'll get 2 by root 5 minus 2 by 5. I'll leave it there, you can substitute. But check out the idea there. Is this logic making sense, everyone? If you stop B, take B ka velocity and put it on the right hand side for everyone. Now B will suddenly think I am at rest and A is going at an angle like this. If you're going at an angle, you're going in a straight line. The shortest distance between two point and a line is a perpendicular. Is this clear? This distance is D. This angle is theta. So opposite side is D sine theta. This total distance is D. So the balance will be D minus D sine theta. This will be the cos theta component. It's all geometry after that. The only thing you did in relative motion is what? Putting the velocity like this. After that, it is all geometry. All clear with this? So you can now try the kinematics problem, which we did in calculus, maximum minima. This question. If you see here, actually it is more easy. If this goes with you, this also goes with you. So this will come to rest. So this angle is 45 degrees, right? You and you both are same. So that is 45. If that is 45, then this is also D. This is also D. If you drop a perpendicular, this will be D sine 45, which is D by root 2. These numbers were more easy. And that was the answer, D by root 5, D by root 2. That is D cos 45. This, see how much you did in maximum minima. If you use relative motion, you'll get it in 2-3 steps. Okay, so that's a bit about relative motion. So go through this. Next class when we catch up, we will do more different variety of problems. So we are done with the projectile motion. So start solving, whatever booklet you're solving. Again, I'm telling you, keep the material simple. You can choose any 2 books. Don't run behind too many materials. It's a waste of time. It will put a lot of pressure on you. You really want to learn physics. You take 1 or 2 materials, do them religiously, do them properly. When I say properly, for example, if you're doing HCV, after finishing all the chapter, if I open the book and ask you any randomly 10 questions, you should be able to answer them without hesitation. You have already done it, right? So there should be no doubt in answering. But what I have seen, right? People will come and say, sir, I finished Cengage, I finished DC Pandey, I finished that book, this book. They do 10 books. You take any one book and ask them how to do this third question or fourth question. You get a lot of sounds. They don't remember. They don't have any idea what they did. Don't run behind this. You will never learn physics like that. You really want to learn physics, you should have a really clarity why you're doing, what you're doing. You should really know end to end why the hell did you even start doing the question that way. You're getting it's very important. Once you get that kind of clarity, right? Because see what will happen after 4 or 5 months down the line, the concepts will become more tougher. So if you just do everything on the surface level, currently chapters are still little manageable. Only for the sake of answers, if you do the questions and get the answers without getting into understanding, after 3 or 4 months, things will be very tough for you to handle. And trust me, you will hate physics. That is not how you learn physics. You're getting it? Meaning, I'll tell you the difference. See, when I was preparing or when your seniors are preparing, right, I see them, right? When they don't get a question, you know what they think? Arey yaar, ye question nahi aa raha, there is something here. They are excited. They think like, there is something here to learn. I'm not getting it. That means there is something I can learn here. But you know what you guys think? You don't get a question. Shit, questions nahi aa rahe mujhe. First thing you start panicking. Because somewhere down the line, it is not your mistake. Because in school, they must have taught you, right? If I give you 10 questions, 10 ka 10 aana chahiye. That is what you learned in school. But unfortunately, in real life, if I give you 10 questions, maybe you'll get one. Sometimes you won't even get that one also. That is fine. Did you see every question that I teach you? How do I teach you? I show you a diagram. I tell you, देखो, इसमें A हो रहा है. It is something. It is happening like that. You need to do the questions the same way when you're solving. You need to really analyze the situation. You need to do this. If you're doing this, it will take time. Again, when you're solving questions, how much time do you spend on a question? Again, depending on the level of the questions. For example, let's say if you're doing something like HCB, maybe you can spend around 6 to 8 minutes per question. Easy question, kar lo 1 or 2 minutes. If it is a tough question, end of HCB, it will take 6 to 8 minutes. Now, what to do in that 6 to 8 minutes? Read the question, try to draw a picture, try to understand what he's trying to say. It is okay if you don't solve the question. Spend 3 or 4 minutes in understanding what the hell he's talking about. Then see if you get any ideas. If you don't get any ideas, then start thinking, okay, did we do something like this in the class notes? You did, you remembered, take out the notes and refer. It should be like a research. Then you see, okay, sir has taught us this problem, but in this problem, it is looking like this. So can I try this? Try karke dekh na, maximum wrong answer aayega. Most of you guys don't want even to try also. I'm seeing this, right? This thing has changed a lot. You guys, until unless you are sure you'll get an answer, you don't even want to try the question. I'm saying you got an idea, right? Try the question, get a wrong answer, then you know your method is somewhere wrong, then go back and see what went wrong. But for some reason, right, people want surety. If I use this method, I should get an answer. Only then I will try to solve. Get it wrong, na? Be wrong 3 or 4 times. What is a mistake? I'm telling you again, if you get scared of doing mistakes, and if you're lazy, that you think you don't want to spend more time, you will never learn. 6 to 8 minutes spend kiya, nothing happened, didn't get anything. That is fine. Leave the question. Go ahead. Go to the next one. Next day, give a gap of at least 1 day. Next day, again, come back to the question, try for 4 or 5 minutes. Trust me, you'll get much better ideas. If you leave it for a 1 day and come back next day and see the question, you will get ideas. You will solve at least 30-40% more questions than normal. People don't have patience. They want answers within 3 or 4 minutes. Tell me one thing. If you want to know about a person, what should you do? If you want to know about a person, what should you do? In your building, there's a watchman or a security guard. Every day morning while you're going, you say, hi, good morning, and you go. I do that with my security guard. I'm doing it from last 2 years. Other than saying hi, I have no idea what he does or who is he or what is his name also. You're getting the problem. You want to know a person, what should you do? Sit with him, spend time, eat with him, ask him, kya kar rahe ho, kya ho raha hai? You do this for a month, you will get an idea what kind of person he is. If every day you say hi, bye, good morning, good evening, and go, you know nothing about the person. You want to learn physics, what should you do? Sit with a question, spend time, and ask the question like, what is happening? What am I doing? Why am I thinking like this? Ask yourself. If you don't spend time with the question, you're not going to learn. And if you're going to spend 6 to 8 minutes per question, in 1 hour, you can't do more than 10, 15 questions. If you can do only 10 questions or 12 questions per hour, you can't solve 400 questions in a week. You can't complete a book. So that is the reason I'm telling you, choose 1 or 2 materials which are not too heavy. Cengage is a very good book, but it has 300 questions. You'll never be able to complete it. So normally for people, I tell them, stick to your classes ka material. You're from PACE, use PACE ka material. You're from LN, use LN ka material. Narayana, use Narayana ka material. Nothing wrong. Materials are good. Everyone has copied from everyone else. So all the materials have good questions. Getting it? So use your classes ka material. You can use my booklet also. That also I copied from Hyderabad Institutes. Right? So you can use a classes ka material. Second thing, you want to do a second book, you can do HCV or do DC Pandey. Bas kafi hai. 2 books. I don't think you should do more than this. You want to do my material, do my material. You don't want to do, don't do. But 2 books to compulsory karna hai. You want to replace this with my material, you can do that. My material has 6 levels. You can do at least level 1 to level 4. Level 5 and 6 are really tough questions. You can spend time on them. Think about what I'm saying. Because this thing right now, everything feels okayish. If you don't spend time, you will have a problem. And your friends will come and tell you, मैंने Cengage complete कर लिया. People like to show off. I did Erudo, I did that book, I did this book. Let them go to hell. What they do is none of your business. Trust me on this thing. It is your journey. Today you scored 30 out of 100. Tomorrow target for 40. Sir, but the other guy got 100. Let him go to hell. That's not your problem. You got 40 today. Tomorrow target 50. You got 50 today. Target 60. 60 नहीं आ रहा है ना? Maintain 50 marks. Maintain the marks. If you can't increase it, maintain it. That is how you study. You don't run behind other people and say like, वो लोग वो कर रहे तो I will do this thing. Every person is different. You see what works for you. I solved HC Verma 3 times. It used to take me around 10 to 14 days per chapter in HCV. My friends used to come and boast every day. मैंने वो किया, ये किया. I said, ठीक है boss, you guys are smart and intelligent, you can do. I am a dumb guy, I can't do so many materials. So I used to take one HCV, I used to do each and every question, why I did, what I did. It's a slow process, but I really understood what I'm doing with each and every question. End of the day, my rank was way better than anyone. Simple thing. They ran behind too many questions. They are, what most people think, let me look at 10,000 questions. इसमें कुछ ना कुछ आएगा ना? But the day when the question comes from this 10,000, you won't even remember how to do that. Instead of that, I am saying do 100, 150 questions, but do them really like, with your heart, like why you're doing and what you're doing. Spend time with them. If something changes in the question, you'll know how to handle it. That is how you learn physics. You start doing that, you will actually love the subject. You will really have fun. But instead of that, if you run behind answers, if you run behind, showing off everyone, I did 100 questions today, I did 120 questions, I did book 1, book 2, book 3, book 4. Yeah, don't run behind that showing off. It'll just make your life more miserable. Stick to 1, 2 materials, do them properly. That would be my only guidance. And trust me when I say this. This I'm telling you from a guy who got 4 zeros in the first 4 tests in physics in 11th. By the end of the program, I was second in the class. My rank was 360 all India, and I'm not joking. I did only HCV. Yeah, Erido thoda kiya hoga while traveling in the bus every day. So anyway, so that is the thing there. Okay, with that, we'll wrap up for the day. So we have almost done 57 questions in the class notes only. I think even if you take these 57 questions and do this, itself will take 3 to 4 hours. So do revise the notes once. Right. With that, we'll wrap up for the day. We'll catch up again on next week.